All right, hey everyone, welcome back to the demo for containerization. So if you guys remember from last class, we kind of started out with this Docker file and this like container kind of like how we use containers to kind of containerize our app and then deploy it onto like a server, external server. So the main motivation behind containerization is to get rid of that like that differential between it working on my computer but not yours or something like that. And we use Docker as like an easy way of first creating those containers and then pushing it to like a central repository where we can just easily pull down from, which is more of what we'll be getting into today. So the very first step of starting with that Docker containerization process is through the Docker file, which we made last time, but we can go through it one more time just to make sure you guys understand. So basically, whenever you create a Docker file, obviously you must have Docker installed. But once you create a Docker file, that's kind of how Docker knows what to do to containerize your app and make it readily available for everybody else. So the way we kind of do things is first, we have to tell Docker what environment we're building in. And if you guys remember from the lecture, the environment is going to be your operating system. It's going to be your programming language, all variables associated, any libraries or packages. And that's kind of all encompassed in this from Python. And then we specify the version as 3.7, basically meaning that whenever you run this container, you're going to need to use Python version 3.7. And that's kind of a way to like you can isolate that version of Python just for that container. And so no other things can like interfere or you can't have any configuration issues because it's basically like starting a new instance of like Python in that container. And then we run make directory, and then we create this directory called user/app. And then we kind of set our working directory to that, meaning any future changes we make in this file, for example, like copying, would happen inside this directory. So we don't have to worry about different levels or different like out of bounds. And then obviously we do copy over all the contents. So if you guys remember from the dot means the current directory. So what this command usually does is copy basically everything from your current directory to the directory you're currently in, which is now user.app. So it's basically mapping from these files on the left to this new hypothetical user/app directory in your Docker container. And then obviously we run pip install the requirements to make sure we have Flask and stuff like that so that we can actually run our Python app. And then finally, there's only one of these. It's the command, the CMD. That's basically Docker's entry point into the app. That's how you initialize the app and get the actual thing started. And then now with this file, we built a Docker image, which if you guys remember from last class, if you type in Docker images, you can see a list of all the images you currently have. Here is mine for this one. And then, yeah, we talked about the different like tags and the repo names. Basically, if you don't specify any of that, Docker will just basically assign anything to that, but that's kind of like weird because you don't know what is what. So the convention we usually do is we put our username to Docker Hub, which we'll get into, and then / the actual project. So in this, we're using the PA4 starter code, so I made it PA4. Does anyone have any questions? That's just a recap of what we did on Monday. And then just one last thing, the way we can run this application is Docker run -p. Basically, -p means port. So we're mapping a container port to our actual machine port. What that kind of means is like on the web, we use ports to specify different things. So usually port 80 is for like web traffic, like HTTPS, or in this case, Flask, which runs on port 8000. So we'll map our Flask app to this Docker container, basically allowing us to connect through the web. So map 8000 to 8000. And then we run it in -it, which means interactive. So that if you guys remember from last class, I forgot to put this tag initially, the flag, and it kind of like used my terminal. I couldn't do anything anymore. So I had to restart Docker to like get the terminal back. And that's kind of what interactive means. It means you can continue to use your terminal as if while having the container running in the background. And then finally, you put the actual name of the Docker container or image, sorry, and then it'll spin up a container for you. And here it is. This looks extremely similar to how it would look if you were to run Python 3 app.py, but now we're running it inside this container. So it's isolated from all the other things on my machine that might like interfere with it. So yeah. Now we'll be delving into something called Docker Compose, which is basically when we want to like organize our containers in a way that's like, this tells us how to like build a container, but to actually control our container and give it like stuff to do or specify extra parameters or stuff like that, we need to use some software called Docker Compose. And basically it's kind of redundant to keep typing in all these ports, the repository name, and like different flags every time we run the app. So we'll just put that in one file. We can just run that one file and it'll just take care of everything for us. And that's kind of what Docker Compose does. It tells us how we can run like individual containers on specified ports along with their own configurations, everything like that. So it's all taken care of. So this kind of ties into how like some apps might have multiple images. So if you think about like, I don't know, Instagram, you have your first like main app container, let's say, and then obviously you'll have another app or microservice to deal with like your email newsletters or like followers following relationships, stuff like that. There's all these smaller parts of the app that can all be containerized and done on their own. And that's why they call it microservices. All these like small tasks that can be done individually, they kind of put that on separate computers to like scale it up and have that like as much resources as they possibly can to allocate to there to basically make it more efficient. So that kind of ties into what we'll do with Docker Compose. So we can create a new file called Docker Compose. And again, this is a special file. So make sure to do exactly like call it exactly how I write it here. Basically lowercase docker dash compose dot YML. YML is short for YAML. It's a kind of like instructional syntax you'll see. I'll show you. And then make sure that's in the same directory as into your source directory. So now we can kind of start. I'll write out the actual Docker Compose file and then I'll go through and explain it again. So we can specify a version. Version is 3. Services. Yep. So we can go through like what this actually means. So the very first line, this version 3, is kind of just saying that we're using version 3. There's not much to like, don't really worry about this. It's kind of like the version of like Docker Compose that we're using. So this one doesn't really matter too much. Just make sure to have that at the top. And then the next thing we want to do is tell like which Docker images we actually want to run on. And the way we can kind of do that is by the services command. So if I were to want to add like another image onto here, I can come down here and add like demo2 and like saying that's a different like image, we can add that there. For the purpose of this class, we're only going to be really like dealing with one image at a time. So we won't actually need that. So basically, and then line 3, that's the services, and then line 4, which is the actual name of the service that we want to do. So we can just call this demo because we're doing the demo. And then line 4 is the name of the actual service we want to use. And then basically, if that was like the Google Maps API, then these services would be called like bus time collector or like something like that, like map view. Basically, the small microservices that you can arrange and individually scale up. That would be this name right here. And then since we're running the demo image, sorry, let me change that to the actual image that we made. So this is our actual image that we created before that we built. And then we specify the ports here. So just as we did here, we specify the ports 8,000, 8,000. We specify it here as well. And then we can just run this file. And then one thing to mention is that if you don't have your Docker Hub like behind your Docker image, then you're going to be able to run it on your local computer, but not really when you upload it to Docker Hub. So if you guys haven't made an account, we're kind of going to go through that a little bit later, just to show you guys how we can push and pull Docker images. And now to actually start up a container from this Docker Compose file, we can come here and clear the terminal. We can simply run Docker Compose and then up. And then what that will do, I'll bring it back up. So this is the actual command that you want to type in. And then you'll see kind of similar like syntax, basically like it's building the images, but they're already built. So it skips that, and then the network, and then it creates the container. And basically attaching here just means that it's mapping the ports. And then now we actually run our app, and we see a similar syntax as you would if you were to just run it locally. Yes. Yeah. The tag. Yeah. So the tag is only really important for like the versioning, pretty much. I think that's how we said it before. The repo name is kind of how we refer to it through Docker. Yeah, that's just how Docker was made. Yeah.
For your image output, is that a
This one?
yeah,
No, so that's the actual image we made before. So if I bring up okay, while it's stopping, basically before this on Monday, we actually built the image. And then if I bring up like Docker images here, you'll see that we have this Docker image along with others for like my side projects and whatever. But basically, this is the image we created like earlier for this PA assignment. And then we're basically just running that image. Yep. Good questions. The image itself. Let me see. 1.03. Good question. Not entirely sure. It has to do with the way that they kind of like compress it. Yeah, I'm not, I'm not entirely sure. Any other questions? All right, yeah, sounds good. So let me start up the Docker Compose again. And you can kind of see like here, we can't really interact with our terminal. Like, if I type in anything, doesn't really work. So the way we can kind of like circumvent that, kind of like the same way when you do Docker run and you don't like put the IT at like the -IT for interactive, then you can't really use your terminal. You can do the same thing, but you can do Docker compose up and then specify this D flag. The D means detached. So basically that means it's detaching from your terminal and it'll like run in the background. So you can still use your terminal while having the container run. So now we know our container is running, and the way we can kind of tell is by running Docker PS, which basically lists all your running containers. So you know to like keep track of whatever you want. So here we have the name of the actual container. Here's the image it was built from, the command to actually run the container. So if I don't think I can actually expand that, but that would say like Python app.py. Created 2 minutes ago, up for 15 seconds, and then it's mapping the ports. So if you guys remember from your assignments, at the very top at the URL, it would either say localhost 127.0.0.1 or this 0.0.0.0 :8000. They all basically mean the same thing, and it all refers to like your local computer. So what this is doing is mapping my local computer's 8000 port to this new container's 8000 port. And that's kind of the way we can like interact with it on the web. And now if we want to stop the container, we can just type in Docker compose down, similar to Docker compose up, but it'll stop the container. And then we can double check that by doing Docker PS, which will list out all the running containers, and we should see that it's stopped. So if we do that, we see there's no running containers. Any questions? All right, sounds good. Now we're gonna go into somewhat of like a different topic, more towards like the security part of like deployment. So if you guys remember from lecture, Tony mentioned about environment variables, these things that we want to keep private and only to us because they're like a security risk if they get out onto the internet. So some of those could be like your username and password to your database, or like an API key, or something along those lines that you want to keep private and only accessible on your local machine and on the server, but not like anywhere in the internet. So the way we kind of do that is through environment variables. And the way we can like set those so they only work in the current environment and they can't be accessed anywhere else. And the kind of way we do that, the way we do that is by creating this special type of file. It's called a .env file. So of course, environment, env is for environment. The dot makes it kind of like a hidden file. So if you were to open this up in Finder right now, which I can show you, where to come to Finder, desktop, PA4 starter, and then oops. Get a source. You won't actually see this .env file that we just created. That's because it's a hidden file. And that's kind of how we want to keep like our secrets like hidden locally. And then through the environment file, we can like create this like secret password that we can share between ourselves and the server, but nowhere across the internet. So to kind of do this, to kind of show you guys an example, so we can create the actual environment variables. So I'll just create like a name environment variable. I'll call it name. And then these are kind of like key value pairs. So basically, you have your key, which is the name, and then your value itself is your use. So you can reference like os.getEnvironName, name, and then it'll basically fill in a use for you. And then we can add another one. So net ID equals 228. And then we always keep these. This is just good coding practice, but whenever you have like something that's constant or like stays constant throughout your entire app, you always want to keep them like in full caps, just so other people know that's like, it's kind of the convention. So wherever you are, whenever you're dealing with like constants, similar to like if you were in Java and use the final keyword, the variable name should also be like uppercase there. So just a small aside for that. And then we can actually use this in our Docker Compose file. So we come down here, we can add this .env file, and then we specify the actual file name, which is .env. And now we can actually see like how we can use these environment variables, because right now we just have them defined. There's not really any purpose so far. So let's actually use them. So as you guys remember, this app.root, this is just, we filled in just a basic root. It'll return hello world. So now we can change this to, let's make it like a greet user one. And so let's document this too. So say this is the endpoint for getting a user by reading the name in .env file. And now we can do return and then hello plus os dot. And then also make sure you import OS here. So import OS, and then here's the actual function. So this is kind of like how we implement the security. So since we're using OS is short for operating system. So our operating system itself is going into this file and grabbing it. And that's how you can kind of isolate it, where because someone on the internet doesn't have access to your operating system, right? So naturally, it would be like good security practice to kind of use that to your advantage, and having the OS go and grab it for you instead of writing down like a use instead of this, would help like mask that. And then now you can actually push this to like GitHub or some online repository where people can see your code, but they won't actually know like what the actual environment is, what the actual variable is. So now we can go ahead and like, I'll show you how we can actually do this through just first through Python, and then we can actually do a Docker container later. Okay. So of course here, let's make our virtual environment. Then let's cd into source and then pip3, or sorry, I need to activate it. And then cd into source and pip3 install the requirements. Yep. And now let's go ahead and actually run this. So as you can see, like the same message from running it, you can get from the Docker container. So now let's open up this address. Did I spell something wrong? Oh, let's wrap that in a string. Okay, well, oh, did we install pip3? Yeah, so sorry, this is the actual command we need to run as well. So pip install .env. And that's kind of how Python knows to like use that .environment file. In Docker, it's much easier where you can just specify right there, but here you can do that. And then now we can see hello, and then the actual thing we have like in our environment file. So now to actually like do this comparison with Docker, we have to rebuild our Docker file because we made some edits to our actual source code. And to get that like into our Docker file, we can just run it again. So we can build the new image. So Docker build. Does anyone remember the syntax for this? Docker build. I'm asking because I actually don't remember it, but let me Docker build -t. I use a or like the name of your repo, and then PA4, and then the dot, yeah. And then that's how we rebuild it. And then notice this one actually takes, this one's actually a little bit quicker than how we would like initially if we were to just straight like make a new image, because now this some of these things are cached, which basically means it's in memory and it's easily accessible, like quickly accessible. So let's create that new image, and then let's actually do Docker compose and spin up our new containers. Services demo, traditional problem. It's not. Um, images ports. What's the they changed the syntax of it before? Is it just could be just that? Maybe yeah, sorry, it was just a syntax thing. I had a dot in front of here, but there's not actually supposed to be a dot. The dot's in front of your actual environment name file. Yeah, sorry about that. And now we can go to the same thing. And now since we're running it on Docker, we get the exact same thing. Since we mapped it to the 8000 port. And yeah, that's how we can kind of use the environment variables in Docker. And now we can actually like use this data to kind of like analyze the actual container. So like, let's say one of our Docker containers goes down, or like there was a bug that caused it to crash. We can kind of do that through, if I stop this container, we can actually analyze like why it went down and like view the logs and stuff like that by another command. So docker exec -it for interactive, and then the actual container ID. Sorry. So the container actually has to be running right now, but we get docker ps, and then we can grab this container ID, and then we do docker exec -it. Then we put the container ID, then we type. And then now we're actually a root user inside the Docker container. So here we can like manipulate everything that's in the actual Docker container. So basically we're in our OS when we run it. And then now we can delve deeper into the actual container and like do whatever we want in there. So we can see inside our container, we have the same exact files. And if I were to like, I can use cat, which means concatenate. It's now that we're inside the container, we're in Linux, which is a different operating system, runs with like different commands. So I can do cat and then app.py. And then we can see it's the exact same thing we have above in that container, and it's running the exact same stuff. But now it's in this isolated environment that shows us that like it can't really be affected by external configurations or something like that. So yeah, and then to exit, just type in exit and you leave that. And now, yeah, so that way we can kind of see like what's going on inside the container and then use that to try to figure out like what goes wrong or anything you didn't want to debug. And then finally, the last thing would be pushing and pulling from Docker Hub, which if you guys know GitHub is like a repository, a big central repository where you can store all your code. Docker Hub is the exact same thing, but for images. So we can go ahead and push this image that we just created, this of the PA4 starter code. So the very first thing you have to do is log into Docker Hub. So this is the Docker Hub website. If you guys don't know, it's literally just search up Docker Hub in Chrome, and then create an account. I'll give you guys a few seconds to do that. All right, everybody good? So now that we have our actual credentials, we can come back to the terminal and we can type in Docker login. And then you can like authenticate with your actual login. So where's my login actually? Yep. So I've logged in. You guys can log in too, or just follow along. So now that we're logged in, we can actually push this image that we created. So this image PA4, we can push that up to Docker Hub. So Docker push, and then use a PA4. And then it will mount, it will create the actual things it needs to do to actually push it. And then now that it's pushed, we should be able to see our image on Docker Hub. So go back to Docker Hub. You can see this is the one I just pushed, last published less than a minute ago. Click on that. We can see all of their information. And then the way we can kind of like pull this down, or actually we can pull down a different image because we pushed this one. So if you're just searching through Docker Hub, but let's say you come across one that's like, well, whale, say, which is this one, it's by Docker themselves. And if you guys are wondering why we love whale so much in this backend course, this is kind of why. Docker's logo is the whale. So that's why best backend wins like whale plushies and stuff like that in the hack challenge. But regardless, this is the actual command to pull it. So Docker pull, and then this is why we said to keep like your username for Docker Hub in front, because that's kind of how you identify different images. So the same way I had a use a in front, this has Docker because it's made by the actual people who made Docker, and then the actual name of the container, which is whale say. So we can copy that. We can pull it, just type that into our terminal here, and then it'll pull it down. Then yeah, so that was successful. And then finally, we can run this. So Docker run, and then let's specify the actual platform we want it to run on. So since we're creating an image, creating a container that's like an isolated environment, we can make it run on any OS that we want. So in this case, let's just make it run on Linux. And special type of like CPU configuration, which is AMD 64. And then Docker, the actual name of the image. I spelled Linux wrong. And then this is the way they set it up. This kind of takes in like parameters too. So we can say class variable. Let's just, I spelled platform wrong too. There should be 2 dashes, I think. Um, let's create 10. All right, so basically the exact same thing here. So we can just copy that. We're getting all the platform stuff. And now we should be able to see the whale, and the whale says boo. Any questions? Yep. Yes. No, so that's a great question. That's actually the same question I asked when I took the course. But basically the big advantages of Docker is the fact that you can like basically create a virtual environment where it's isolated from everything else. So the way with GitHub, you can just go and you can clone a repo, bring it down, but that doesn't mean you have all the same config files, settings, environment variables. And another thing about GitHub is that once you launch like an app, like let's say I SSH into a server somewhere, I want to run an app there. If I start running my GitHub app, the terminal is kind of locked up. Whereas with Docker, we can run a Docker compose, we can run as many containers as we want. So we can have all these like different microservices running on the same like Docker engine versus GitHub, where you'll have to create like, separate instances for all of those programs. Sorry, can you say that? Yeah, so when you install Docker, it's kind of like Docker itself just organizes containers kind of. And then you can put containers on top of it. It's exactly like Docker itself is the whale here. And then the actual containers or the shipping containers are your little applications of code. So yeah. Yep. All right, sounds good. So that was the end of the demo. We can get into the Kahoot now. So